Hi there, folks. Today we're looking at fitting lines to data. And the first thing we need to do is determine if there's some kind of pattern in terms of the data we're looking at, all right? And we call that correlation, all right? So correlation is if there's a pattern exists, if there's a relationship between the two things, all right? That's this whole idea of correlation, all right? For lines, for our purposes, we're only looking for the pattern that kind of represents a line. And so when you look at this, they're not perfectly lined up, but we have positive, negative, and no correlation. Positive correlation means the thing kind of looks like a line. And granted, if I draw a line through here, it's not going to touch all the points. They're all not all lined up. But if I were to draw a line right down the middle of this, the question really is, is that line a good estimate of those points? All right. And when you see all the points are kind of hovering around that line, so that line would be a good estimate or a good approximation of those values. So we say that the data kind of looks like a line. All right. So it's estimation. It doesn't have to be exact. It has to be close. Yeah, it looks like it's all kind of piled around that line. So we call that positive correlation because it represents a line with a positive slope. All right. And the idea there is that one value is going up as the other value is going up. There's a positive correlation. They're going up together. Okay. Negative correlation, likewise, if I look at this thing, yeah, it's not an exact line, but it kind of looks like a line. If I were to draw a line right down through the middle, does that line give us a good estimate of those points? And the answer is yes. All the points are kind of hovering around that line. So that line would be a good estimate of the points. And notice that line has a negative slope, so we call it negative correlation. In other words, as one value goes up, as the x values increase, the y values are going down. So like the relationship between those two values is kind of reversed. As one goes up, the other one goes down. We call it a negative correlation. And then no correlation just means that there's not really a pattern here. All right. If I were to try to draw a line and ask myself, hey, is that line a good estimate of those points? Well, not really. They're kind of all over the place. It's like if I were to draw this line. Is that line a good estimate of the points? Well, it's about as good as the other one, but still not very good. Is this line a good estimate of the points? Well, no, not really, but it's about as good as the other one. See, there's no line that kind of gives me a good estimate of the points. So we say there's no correlation here. And the idea behind correlation is if there's correlation and it looks like kind of a line, I can write an equation of that line, okay? And so that's what we want to do. We want to write the equation of that line if the correlation exists, okay? If there's no correlation, I simply can't do the thing, okay? So if a positive or negative correlation exists, the data can be modeled by an equation. And so here's what we do. We draw a scatter plot, which is essentially us just plotting the points. We take whatever data values are given and we just plot them. That's what a scatter plot is, okay? And that'll tell us if this thing has positive or negative correlation, okay? Or if there's no correlation. If there's positive or negative correlation, now we can draw a line, all right? And typically when we draw the line, we'll use 2 points. They can be any 2 points. Here it says 2 data points, all right? It doesn't have to be data points. Some students just really like to use data points. I prefer to use any 2 points because I can make it easier for myself, okay? The data points are nice because we can literally see them and we know exactly what those points are, but any 2 points will work as long as it looks like a line that looks pretty good, all right? So then we're going to write the equation of the line just like we've been practicing, all right? We'll put the thing in point slope form, and then we'll rewrite it in slope intercept form, something like that, okay? And then what we'll do is we'll kind of use that equation. The whole point already of the equation is if the equation is a good estimate of the data, we can use that equation to plug in more values and get predictions using the equation, okay? Here's another example. And again, this time, that's the value I'm going to predict is the 20. And so I have each of these kind of as an ordered pair here. It's the number of dragons and the number of unicorns. As the dragons go up, the unicorns go down because obviously the dragon is a natural predator of the unicorn, okay? So again, this is my x values and my y values. And I'm just going to kind of go through this. Let me label this guy. So let's see. This is 1, 2, that's 3, 5, 7, 9, 11. Okay, so I just went by ones. I labeled every other so that my handwriting didn't run into itself. I don't know why I did green that time. I just did. Going up and down, here's a neat trick that instead of starting at 0, you can just put a little zigzag in here and start at something like 300. All right. The nice thing about doing that is that you don't have to count all those values starting at 0. That little zigzag means, hey, I skipped a couple, and that's fine. All right. We just want to get an idea of what these points look like when I graph them. All right. So now from 300 to 1300, it's about 1,000. So I'm probably going to have to go by maybe 100 or so here. So that would be 400, 500, 7, 9, 1100. And I almost came up a little short. I could just squeeze this one in here, 1300. Again, it's an estimate, all right? That maybe wasn't the best scale to use. I maybe could have done a little bit better, but it's an estimate. As long as we can kind of get it on the graph and have some idea where that point is, that's all that matters, okay? And so now I plot these points. 1, 1322 is right up here somewhere. 3, 1, it's going to be right around up here somewhere. 5, right around that 900 mark. 715, going to be just a little bit up from that. 9, 483, a little bit down from that guy. And 11, 301 is going to be right above that guy. Okay? And so once again, I look at it and say, hey, does this look like a line? The answer is yes. And so I draw a line that looks good. And see, this one's neat because this one, maybe let's try doing rise over run. So here we go. I've drawn this thing, and it looks like I could kind of count the slope here. And this is why this can be a little bit tricky. You just got to be a little bit careful. Looks like you got a point here, point here. Yeah, it looks like a pretty consistent slope. Okay, looks like down 2 over 2, down 2 over 2. But keep in mind that's down 2 blocks over 2 blocks. Okay, over on this side, each block isn't 2 units. It's 100 units. So down 2 is actually down 200. Okay, so when we do the slope, let's do rise over run. It's down 200. And then over, down here, 2 blocks is just 2 units because I'm going by ones. So you just have to be really careful there. So the slope here looks like a negative 100. And so last time I picked 2 points off the graph, we can do that here, write it in point slope form, and then convert it. Or I can just do rise over run from the graph. We just have to be careful with the scale. And then right up here, I can even look at this guy. Ready? If I keep that slope going back to and then up to, that's up 200. And right here, so that's 1,300, 1,400. So that's a good estimate for the y-intercept. And that's why we looked at all these different methods for writing equations line, because it makes stuff like this easier. So we can just do an estimate. Okay? So now here's my estimated value. Ready? Y equals negative 100x plus 1,400. And so now I have an equation that represents x as the number of dragons as y as the number of unicorns. There it is. Okay? But again, it's an estimate. And your equation might look a little different than mine, but that's okay. The follow-up question to this, oh, sorry, I forgot to do the predicted value. At 20, let's see what would happen. So if I plug a 20 in here, sorry, it's jumping around. So if I made a predicted value, again, that's my equation, just plug the 20 in. And again, this is a job for your calculator. So we go ahead and plug that bad boy into the calculator. Negative 100 times the 20. It's going to give me a negative 2,000 plus the 1,400 gives me a negative 600. Well, let's interpret that. Does that even make sense? Can I have negative 600 unicorns? And the answer is no. What that means is at some point unicorns went extinct. I ran out of unicorns because there were too many dragons. Okay? And yeah, this is a ridiculous example, but so then the follow-up question to that, okay, that was my predicted value, which still gives me information, even though negative 600 does make sense. What's the approximate number of dragons that will cause the extinction of the unicorns, right? So again, here was my prediction equation. Well, we just have to think about what each of these things represents, right? Y is the number of unicorns. So this is the number of unicorns. And X is the number of dragons. So extinction of the unicorns would be a y value of 0. So I plug a 0 in here. It's asking me for the x-intercept. Okay? And so now I can solve this thing. But again, it's all about estimation here. We're estimating a line that looks good. We're estimating the equation of that line so that we can use that to estimate future values, okay? And now we divide each side by a negative 100, okay? And so the answer I get, 14. X equals 14. In other words, once I have 14 dragons, that's when the unicorns go extinct, okay? And so again, that's a silly example, but the idea here is we want to look at the data and say, hey, does it look like a line? Sure. Can I draw a line that looks like a good estimate? Yeah. What's the equation of that line so that I can make predictions about other values so that I can estimate certain things in the future? Okay?